In addition to emitting heat and light, the Sun also emits intense radiation. Therefore, in order to protect the planets from radiation, it is necessary only to have an atmosphere in them. In addition, they need a magnetic field. Our planet has both, but our next-door neighbor and planet closer to the Sun than ours has almost no magnetic field. This is surprising because Vinera is so close to our planet in size and density. The similarity in size and density between Vinera and Earth suggests that their internal structures are similar. Like our planet's core, Vinera's core may be partly liquid because the two planets cooled at about the same rate. But it cannot be ruled out that Vinera has a completely solid core. The radius of Vinera's core, based on planetary models, is estimated to be between 2,900 and 3,450 kilometers. Without mirror seismology or information about its moment of inertia to inform Venus' internal structure, there is little direct information about the planet's internal structure and geochemistry. Because Venus is slightly smaller than our planet, the pressure at the center of its core is 24% lower than the pressure at the center of our planet's core. Venera's lack of a magnetic field is due to its lack of an internal dynamo, and Venera has a weak induced magnetosphere. This layer is located at an altitude of 48 to 54 kilometers, similar to Earth's, and the weak layer provides negligible protection from the Sun and cosmic radiation. This is the result of the weak magnetosphere around Venus directly interacting with the solar wind with its outer atmosphere. Here, as a result of the separation of water molecules from ultraviolet radiation, hydrogen and oxygen ions are formed. Solar winds then provide energy that helps some of the cosmic radiation escape into space from the planet's gravitational field. The cosmic radiation protection system on our planet works completely differently. It has to do with the internal dynamo. A dynamo requires three things: first, a conductive fluid; second, circulation; and third, a convective process. The core is believed to be electrically conductive, and although its rotation is often thought to be very slow, simulations have shown it to be sufficient to produce a dynamo. This means that Venera's core lacks convective motion, whereas it would be expected to have a dynamo as it is similar in size to Earth. On our planet, the convective state occurs in the liquid outer layer of the core. Because the bottom of the core is hotter than the outside. The calculations show that a global rewarming event on Venera's surface shut down plate tectonics, resulting in reduced heat flow through the crust. This insulating effect causes the mantle temperature to rise, which in turn causes the core to heat up even more. In this process, the temperature is almost the same both inside and outside the core. As a result, there would be no internal geodynamo to drive the magnetic field. Although Vinera is similar in size to Earth and has a hot liquid metal core like Earth's, it is concluded that this difference is the reason for Venera's lack of a magnetic field. Another hypothesis proposed to explain the absence of Venera's magnetic field is the absence of a late major impact on Vinera, similar to the Moon-forming Earth impact, which would not have allowed convective processes in Venera's core to sustain. Another hypothesis is that Vinera had a magnetic field and maintained it for 2 or 3 billion years before losing its dynamo. Vinera is thought to have kept water on its surface until the dynamo disappeared. If we look at this hypothesis, it turns out that Vinera lost its surface water reservoirs not at the beginning of the planet's evolution, but recently. The crust of our planet is in constant motion. Vinera does not have such a process. The surface changes of Vinera are mainly caused by volcanoes. Even Vinera has more volcanoes than any other planet and is much bigger. This is because Vinera exerts high temperature pressure on the outer crust to remove heat from the mantle, causing the crust to thin, and then subduction occurs on a massive scale over about 100 million years, completely reworking the crust. About 80% of Vinera's surface is covered by smooth volcanic plains, 70% by wrinkled ridges, and 10% by smooth plains. Two mountainous continents make up the rest of its surface, one in the planet's northern hemisphere and the other south of the equator. The northern continent is about the size of Australia and contains Mount Maxwell, the highest mountain in Vinera, with its summit 11 kilometers above Vinera's average surface elevation. This peak is the coldest point in Vinera. The temperature there is about 380 degrees centigrade and the atmospheric pressure is about 4.5 megapascals. The southern continent is larger than two mountainous regions, roughly the size of South America. A network of cracks and fissures covers most of this area. On the summits of the high mountains of Vinera, white snow-like objects similar to those on our planet have been detected, and they are definitely not snow or ice. As we said, most of Vinera's surface was formed by volcanic activity, and several lines of evidence point to the presence of volcanic activity on Vinera even today. Investigations carried out to date have shown that the concentration of sulfur dioxide in the upper atmosphere of Vinera decreased by 10 times between 1978 and 1986. Increased in 2006 and decreased again by 10 times. This indicates that sulfur dioxide levels have increased as a result of large volcanic eruptions. The first direct evidence of ongoing volcanism at Vinera was discovered in 2008 and 2009. The shield volcano Mont Mons was recently observed as 4 transient localized infrared hotspots. These spots represent lava from volcanic eruptions. At this location, the temperature rises to about 827 degrees centigrade, while Vinera's normal temperature is 467 degrees centigrade. Venus has more volcanic craters than Earth, not because Venus is more volcanically active than Earth, but because its crust is older. Because the erosion process is not the same on Earth and Vinera, the recycling period of the Earth's oceanic crust is on average 100 million years. And the recycling period on the surface of Venus is estimated to be 300 million to 600 million years on average. Therefore, it is not surprising that there are many craters and scars on the surface of Vinera and that they are in a clean state. Volcanoes release large amounts of sulfur dioxide and many other chemicals into the atmosphere, including water vapor. But water vapor is forced to escape Vinera's atmosphere for many reasons. Due to the large number of volcanoes on Vinera, the percentage of water vapor in its atmosphere is very small, in other words, only 0.002%. And our planet has a very favorable environment for saving water vapor released by volcanoes in this regard. That's why there is life on our planet, that's why we are studying Vinera from Earth, and that's why no one is studying us from Vinera.